Hello everyone, it's the first lab session. So in this lab session we're gonna study about operational amplifiers, or in short OpAmps. So we're gonna test today and we're gonna try to actually experimentally see how OpAmps are working. So initially we're gonna see how the basics OpAmp configuration can be work. So here what we have for lab session is the prototyping board that the ready circuits are printed on the PCB. So we're going to use them for testing, for experimental results, for experimental setup. So for setup, what we need to have, first of all, we have to need this PCB. Then we have to have the signal generator that's gonna produce signal. In our case, we're gonna produce the sinusoidal signal. Then we need to see the output signal. The output signal we're gonna see through the oscilloscope, and also we need to have a power supply, DC power supply. So first of all, when you have this board, you have to get familiar with the all component that comes with this PCB, like with this lab kit. So with this lab kit, apart from this PCB, you're gonna have also these packages that have the jumpers, different type of jumpers. And so basically all resistors and all ICs, all the active components and passive components are already soldered and connected to the PCB. So all we need to have to do in this lab session is to connect those jumpers to particular connections. So let's start. First of all, in order to this PCB to work, we have to actually power this board. So we have to connect to this main power. So as you can see here, we have connections, ports is plus 10 volt, ground, and minus 10 volt. What we have to do, we have to take two jumpers, like for example red jumper for plus 10 volt and black jumper for minus 10 volt, and connect them to the power supply. So what have to do, you have to connect the red jumper to plus and black to minus, and set your power supply to 10 volt. And in the current, set as a default values. If you're gonna have not enough values here, you should have to increase the current. So I'm gonna show how it works actually by the way. So first of all, once you connect it, so in order to connect this jumper to here, you have to unscrew a little bit here, make it space, put jumper inside, and screw it tightly again, so it won't fall off from the port. So once you connected the power supply, now you have to connect the jumpers to the circuits. So we're gonna study here three types of circuits for pumps. It's unity gain, when there is no resistor, just directly connections, the inverting type, and the non-inverting type of our pump circuits. Okay, first of all, we're going to start with unity gain. So as you should already know, what is unity gain of pump? It's just the connection when we connect either minus either plus to the input, and other port we connect from the feed line without resistor to output. So just we're gonna have a loop without resistor. As we can see here, the feed line, the loop line, is connected from the output to the in. So in our case, I'm connecting the feed loop to the minus, to the output, and plus to the pulse. I'm connecting the input signal that comes from the signal generator. So once you connected this loop jumper out to minus in, you connect this jumper to the signal generator. Signal generator produces a signal, but see, the signal comes it should have plus and minus. Plus where the signal goes, this wire, and the minus is ground. So plus wire goes to the orange wire, this wire, and goes to the plus of in plus. And another wire, yellow wire, which is ground, should go to the ground. Okay. And to see the output, the oscilloscope, we connect the output port. This output, this wire goes to the oscilloscope. And as we can see here, also we have to connect plus and minus. Plus goes to the output, and minus the purple wire goes to the ground. Okay, once everything is connected, we have to set up our signal generator. So for signal generator, let's start. So we're gonna use the initial frequency as a 10 kilohertz, and the amplitude is 1 volt peak to peak. Okay, and the waveform is a sinusoidal waveform. So you press. So it depends on which signal generator you're using. So we're gonna turn on the channel 1, and so we can see the signal goes to oscilloscope. So we have the signal, and also we have to turn on the power supply. Channel 1 off, and also this one. See, if it's green it's okay, but if it's gonna red, so it means you don't have enough current, so you have to increase slightly current until the green voltage is gonna be full green voltage here, like this. So, and now we can see what we can see here. We can see the sinusoidal output. Since it's a unit gains, it means gain is 1, so we don't have gain. So with the input of 1 volt, we're expecting from the formula sinusoidal signal of 1 volt. As you can see, is 1 volt peak to peak. So let's try. If we're gonna increase the input signal from 1 volt, let's say, to 2 volt. Press auto set if it's out of scope. Now we can see it's 2 volt. Let's try to increase further and see until what the range, actually input range of this amplifier. So we're gonna see until what the input amplitude. We're gonna see the distortion or clipping of this output signal. So let's go to increase 3. It's 3, 4, 5. Press auto set. Still sinusoidal signal, perfectly 5 voltage. 6, 7. Let me remove this one. 8. Now we're gonna see the clipping. See, the clipping is happening because it's out of range. It's like the outer range of input signal of this amplifier, and it actually depends on the biasing, the DC biasing we're providing. Since we're providing DC voltage of 10 volt plus minus 10 volt, it cannot go below the 10, but as we can see, it's already starting distorting at around 7-8. So there is like a room of 2 volt you should have. If you want to have like output of 10, so DC should be not less than 12 or 30 volts in this case. Let's see what happens if we're gonna increase to 10, like 9, 10. See, the signal doesn't increase much. It increases, but it's clipping, so it's like doesn't go above the 8 voltage. But let's see what's gonna happen if we're gonna increase the DC biasing, the voltage of DC supplier. So choose voltage. We go to 11. It increases, but still it's clipping. I'm gonna increase to 12. Now clipping is decreasing. Yes, 13, 14, 15. Now sinusoidal is full sinusoidal. So as you can see, we need to have some room for output signal to see the full signal. But try not to increase very high DC power, because if you're gonna supply very big voltage, it actually can damage the circuit. So we're gonna go and see what happens if we're gonna increase further to 11. Clipping is happening. 12, 13, 15, 14, 15. Let's go to increase the biasing slightly. So voltage 16, 17, 18, 19, 12. So we're having the gained amplified the signal, which is amplified by the amplifier. So from the basically it's not amplified because we're using a unity gain. So for 15 we are having the 15 output, but the DC should be like above, so it's 20. So it's going to be now it's good for enough. Don't try to increase more than 20. It's gonna work, but for safety we're not gonna increase more than 20 for now. So now it was unity gain. Now once we did unity gain and understand how everything can be connected and work, now let's try to do the inverting configuration. When we feed input sinusoidal signal to the minus input, and the plus input goes to the ground, and instead of using just jumper, we're going to use actually resistors, two resistors as a feedback loop. Okay, so what now we should do here, we should connect the plus input to the ground, and as we can see here, we have this set of the resistors, a set of capacitors. For now we just need to have like resistors, and as we remember from the schematics of the inverting OpAmp configuration, we need two resistors, one resistor that goes to the input, minus input, and one resistor that having a feedback loop. So let's choose the input resistor 1 as a 1k resistance, 1k ohm. So this is orange wire goes from the input. So signal goes from the signal generator, then it goes to the resistor 1k, and then after resistor 1k it goes to the minus input. Okay, and the second resistor, we take a resistor of 2k, which is connects like the 2k resistor. The minus goes to the 2k and it goes to the output. So there is a feedback line loop. So from output it goes back to the resistor 2k and come back to input minus. So you have to connect this feedback loop jumper from output to the 2k resistor, and connect the input signal to the 1k resistor, connect the plus port of OpAmp to the ground, and the connection of the signal generator remains. So one goes to ground and the plus goes to the input, and the oscilloscope is the same, ground minus goes to the ground and the output goes to the plus of this goes to output. So we can see the output. We set one same frequency, 10 kilohertz, and 1 voltage peak to peak. Set same debasing, 10 voltage. And once we turn on everything, as we can see, we have 2 voltage output. What do you think? Why it happens? Why with 1 voltage input we're having 2 voltage output? The reason is the ratio between the forward back resistor RF is to the input resistor is actually 2 divided by 1 is 2, so gain is 2 of these configurations, and from the forward minus RF divided by Rin is gonna be, in our case, is 2. As we can see, is 2 voltage, and as we did previously, if we increase the voltage from, let's say, 2 voltage, it goes to 4, 3, 6, 7. Now, as we can see, it's clipping. It's due to the biasing condition that we have a 10. So as previously we did, if we increase the biasing condition, let's say to 15, yes, to give a room, clipping is gone, and we have a full 8.4 voltage out of 4. So it's not exactly 4. There is actually some. It's gonna be distortion, discrepancies from the result due to some jumper effect, or maybe they can actually add additional resistance. So there is actually not pure 2 gain is gonna be here. And so as you can see, the inverting type of OpAmp is working right now. So what we did, we connect this input with the 1k resistor and connect the feedback loop with the 2k resistor. So and what's your task is here, actually try to repeat the same configurations and try and record all input to output results starting from the 1, say, to the 10 voltage peak to peak, record when you have a clipping and how you actually can reduce this clipping. Okay, and try to do also same that we did and also for the other configurations. Now for next stage, for next step, for now we're going to do the third type, is a non-inverting OpAmp configurations. For this configuration you have to like swap plus minus input of the OpAmp. So before the plus went to the ground, we remove this ground and connect the ground to the minus, and previously the minus input 1K, which goes through from the input signal generator, we directly connect to the plus. So input signal goes directly to plus, so it's non-inverting topology, and the same two resistors, but now the 1K resistor goes to the ground. So 1K goes to the ground, then the forward loop, feedback loop 2K, and the plus goes directly from the signal generator, and the output the same. So now we turn on. Turn on everything, and we can see here with the 1 voltage peak to peak we're getting actually roughly 3. This is due to the formula, which is 1 plus divides the ratio of RF feedback resistor to the R in. Since this RF is 2 and RF in is 1, so 2 by 1 is 2, plus 1 is 3. So now the formula which we used actually can be seen experimentally. Let's try to do the same procedure what we did before, increasing the voltage. So we're increasing. Now it increased according to new formula. So from 2 volts peak to peak, it goes to actually 6.5 roughly. So why it's happened? So it happens because 2 times 3 is 6, yeah. So the gain is 3. Now 3 volts input, we're getting 7.8. As we remember, around 8 volts we're having clipping due to this 10 voltage, and if we increase again, let's say 15 up to, or 20, the clipping is gone. But since its gain is not 2 but 3, still have small clipping, so let's increase up to 20 to make sure that the clipping is gone. Yeah, clipping is gone, the sinusoid is full, and we have almost 10 voltage from 3 voltage peak to peak input signal. So now we did all 3 types of circuits. So the task is for you actually repeat like everything that we done today. So what we did the unity gain, inverting topology, the circuit type, and the non-inverting circuit type of the amplifiers. So you should repeat the same procedure and also record for different type or for different frequencies and for different input voltages. So start from the 1 voltage peak to peak to 10, and also do for different frequencies, start from 10 kHz, 100 kHz, 200, 300, 400 up to 1 megahertz, and see how actually output is changing. Is distorting, is amplitude changes, if it's changing or decreasing, and why it's happened, and record is everything in the table in this report. So this is end. So thank you for everyone, and please ask me the question during the lab sessions if you have any.